Bismillahir Rahmanir Rahim. Welcome to the Rising Star Academy. Today we will learn or we will make some double angle formulas and their derivations with the help of sum or difference, simply sum to product form. Now, in this question, I will replace angle B with A. So, in the next step, that would be sine of A plus A. So, where we have B, we will replace with A. In the next step, we will add these two A's. So, that will become sine of 2A is equals to sine A cos A plus, we can write this in order like sine A and cos A. So now this is 1 sine A cos A and this is also 1 sine A cos A. So that will become 2 sine A cos A. So this is the proof of double angle formula. Now from this proof we can make a derivation with a half angle. So let's see. So here we can see that the sine of 2A is equals to 2 sine A cos A. Now for making the half angle, I will divide each angle by 2. So in the next step, that would become sine of this 2 is cancelled with this 2. So now I have left sine A is equals to 2 sine A by 2 into cos of A by 2. So this is the derivation from double angle to half angle. Now we will prove the next formula for cos of 2A. Here in this formula, we will replace the angle B with A. So now in the next step, I will write cos of A plus A sorry dear, we will replace angle B with angle A. So now we have cos of A plus A, that would be cos A into cos A minus sine A into sine A. So every B is going to replace with A. Now when cos A is multiplying with cos A, that would become cos square A minus sine A multiply with sine A, that would become sine square A. And here we have cos of 2A. So our first identity is proved, this one. Now from this identity we'll make another identity for the double angle, but before making the other one we will make a half angle from this. So we know that for making the half angle, I will divide the angle with 2. So now this 2 is going to cancel with 2. So we have cos of A is equals to cos square of A by 2 minus sine square of A by 2. So this is our half angle identity from double angle. Now we will prove the other identities from this double angle. So we know that cos of 2A is equals to cos square of A minus sine square of A. So for the second identity, we know that sine square A plus cos square of A is equals to 1. Now I will make subject for cos square A. This sign will move on the right and that would be subtracted. So 1 minus sine square A. So I would replace this cos square A with 1 minus sine square A. So cos of 2A is equals to 1 minus sine square of A, and this sine square A would be written as it is. In the next step, we have this is minus 1, this is minus 1, so it would be added and that would become minus 2 sine square A. So this is our second identity from the double angle which I proved. Now we can make it as a half angle. So by simply dividing the angle by 2. So this 2 is cancelled with this 2. Now we have cos of A is equals to 1 minus 2 sine square A by 2. We can also rearrange it. So I will move this on the left side and this value on the right side. That would become 2 sine square of A by 2 equals to 1 minus cos of A. This formula can be used in trigonometry. Now we will prove the third identity for the cos of 2A. Cos of 2A cos square A minus sine square A. Now I will change this sine square A. So we know that sine square A plus cos square A is equals to 1. So if I want to make subject for sine square A, that would become 1 minus cos square A. Now I will replace the sine square A with 1 minus cos square of A. In the next step, we will remove the bracket. So cos square A minus 1. Due to this negative sign, the sign would change. That would become plus cos square of A. So now This is 1 cos square and this is also 1 cos square a. So finally that would become 2 cos square of a minus 1. That is cos of 2a. Now we will make it in a half angle. So in next step, I will divide this angle by 2 to make it half angle. So now this 2 is going to be cancelled with 2. So we have cos of a is equals to 2 cos square a by 2 minus 1. So this is our next half angle identity. We can rearrange it. So 2 cos square of a by 2. I will shift this negative 1 on the other side, so that would become 1 plus cos of a. So 1 plus cos of a is equals to 2 cos square of a by 2. Now we will prove the tan double angle identity. Here we have tan of a plus p, that is tan of a plus tan of p over 1 minus tan a times tan b. So I will replace the angle b with angle a. So in the next step, I will write tan of a plus a, tan of a plus tan of a divided by 1 minus tan of a into tan of a. So this b is replaced with a. Now I will simplify. So 1 tan a and this 1 tan a, that would become 2 tan a and in the denominator it would be 1 minus tan a is multiplying with tan a, that would become tan square a, and here we have tan of 2a. So we also proved this double angle identity. Now we will prove some trigonometric identities from exercise 1.4, question number 4, by using these. So let's start now. In this question, to prove the trigonometric identity, we can take either the left side or the right hand side, but I will take the right hand side, that is the bigger side basically. So I will choose the right hand side. So let me write that as tan of x minus sine of x over 2 times tan of x. Now we know that tan of x is equals to sine x divided by cos x. So I will replace the tan x with these two. Let's write sine of x over cos x minus sine x divided by 2 times sine x over cos x. In the next step, I will make a fraction, so we can write it sine x over 1, because sine x over 1 is sine x. It would help us to make the LCM. Now we know that in LCM the denominator value should be same, so I would multiply here with cos x in the numerator as well as in the denominator. So for the next step we will write it sine of x over cos x minus sine x times cos x over cos x, and it would be written as it is. Now we will take the LCM, that would be cos x so sine x minus sine x into cos x, then we can divide it by whole with 2 times sine x over cos x. Move to the next page now. I write the previous as it is. Now I will simplify. So we know that in both fractions the denominator is with cos x, so this cos x is going to cancel with this cos x. Now we have left, that is sine of x minus sine of x times cos x over 2 times sine of x. I will take sine x as in common from the numerator. So now I have 1 minus cos x. In the denominator I have 2 times sine of x. So this sine x is going to cancel with this sine x. The left I have, that is 1 minus cos x divides by 2. Here we want to prove the formula for the double angle, that means sine square x by 2. This is our required answer. So we will convert these value from half angle. Okay, dear students, here we proved that 1 minus cos of A is equals to 2 sine square A over 2. If I replace this with x, so that would be 2 sine square x by 2 is equal to 1 minus cos of x. So I will use this formula over there. So I will write here, that is 2 sine square of x by 2 over 2. So this 2 is going to cancel with this 2. We have sine square of x over 2. So this is my final answer. Now we'll move to the part B. In part B, we can see that the left side is bigger than the right side. So I will take the left hand side. That would be 2 over 1 plus cos x minus tan square of x by 2. So we know that, and we prove that the formula for 1 plus cos x, let me show. Okay, here we will write the double angle formula. We know that cos of 2x is equals to 2 cos square x minus 1. If we make it half angle for cos of 2x over 2 is equals to 2 cos square x by 2 minus 1. So now we have cos of x 2 times cos square x by 2 minus 1. Now I will rearrange. Negative 1 will go on other side, so it would become 1 plus cos x, that is equals to 2 cos square of x over 2. So this is my required formula that I would replace over here. So I would write 2 divided by 2 cos square of x over 2 minus the tan square x by 2 can be written as sine square of x by 2 over cos square of x by 2. In the next step, this 2 is going to cancel with this 2. So we have 1 over cos square of x by 2 minus sine square of x by 2 divided by cos square of x by 2. Now I will take the LCM. That would be cos square of x over 2 when denominator are same, so numerator can be written as it is. Move to the next step. I rewrite the previous value over there. Now we know that sine square a plus cos square a is equals to 1. If I'll shift this value on the other side, so we can say that cos square a can be written as 1 minus sine square of a. Now I will make the half angle by dividing the angle 2. So now we have cos square of a by 2 equals to 1 minus sine square of a by 2. Now I will replace this value over there. So that would be cos square of x by 2 over cos square of x by 2. Both are same value, so both are gonna cancel out. We have 1, that is our required right hand side. Now we'll move to the part C. In this part, we will take the right hand side to prove the left hand side. So we'll take the right hand side, 2 cos of theta over 1 plus cos of theta. We want to convert this value into half angle. So now in the next step, we will write 2 cos of theta, and we know that 1 plus cos theta, that proved in the previous part is equals to 1 minus sine square of a by 2. So 1 plus cos theta, sorry, in this part, 1 plus cos of theta is equals to 2 cos square of x by 2. So I will put this formula over there. That is 2 cos square of theta by 2. What about the cos theta? For cos theta, we know that the cos of 2 theta is equals to cos square theta minus sine square of theta. Let me rewrite. Cos of 2 theta is equals to cos square of theta minus sine square of theta. When we will make the angle half by dividing the angle 2, so now we have cos of theta is equals to cos square of theta by 2 minus sine square of theta by 2. Now I will replace this value in place of cos theta. So we'll see in the next step. Now I will replace, so that would be 2 times cos square of theta by 2 minus sine square of theta by 2 divided by 2 times cos square of theta by 2. In the next step, this 2 is going to cancel with 2. So we have cos square of theta by 2 minus sine square of theta by 2 divided by cos square of theta by 2. Now we will separate them. So cos square theta by 2 divided by cos square of theta by 2 minus sine square of theta by 2 divided by cos square of theta by 2. The rule is that when we have a plus b divided by c, so we can separate them by writing a over c plus b over c. So I did the same thing over here. I separate them. Now I will simplify. So this cos is going to be cancelled with this cos. We have 1 minus sine square over cos square will be written as tan square of theta by 2, and that is our required left hand side. Thank you very much.